Hi, I'm Mark Smith with Macroscopic Solutions. And today we're going to be moving on to the second of four tutorials in the 3D imaging series. So we're going to be using the Macropod Pro 3D. The previous tutorial discusses how we set up the hardware before we go into capturing the data for our 3D model. In this tutorial we're going to be talking about how to position and record the data for your 3D model. So we're going to be capturing all of the images using focus stacking in combination with using the rotary stage to collect perspective around the sample that we're choosing the 3D model. Okay, so some things I failed to mention in the first video, which are important to say now, is that it's really important to have fresh AA batteries. We always use rechargeable AA's, but fresh AA batteries in the flash because this is a long process, longer than normal. So to keep everything running smoothly, depending on how long it is you're going to be doing the imaging, fresh batteries are good. You should be able to get at least 6 hours of continuous use with fresh AA's. So once they're on, the next thing we're going to do is position the sample. And today, what we're going to be using is this black bee that's mounted on this stage. For background color, you can use just about anything. You can take the same green screen idea for 3D modeling because we're going to be eliminating pixels later from the photographs, either through masking or just in the software. I choose not to use a green screen just because sometimes the green will reflect onto the sample. You'll get some sort of an artificial color. So neutral gray, white, and black are my preferred choices for setting up a background. And the way that I accomplish that is usually through using felt. So I have a folder, just a duplex folder here that I've wrapped in black felt, so you can just set it up behind your image. That way you can have black. But because I said that the bee is somewhat darker in color, we're going to be using white felt. So for that, what we can do is just position that folder still behind where we're going to be mounting our specimen on the stage. And we could just take the white felt, and because it's got a pretty high friction, when you basically touch felt to felt, almost like Velcro, you can just stick it on the back and it will sit, and now you have a good white background. But also because of the distance that I position the folder behind the sample, we're actually going to get more of a neutral gray look. That way, well, one, it's just more important again for eliminating pixels at the end, and two, we're not too focused on what the background color is going to be because we're creating a 3D model. We can edit that later. So to position a sample, it's always good to have your desk lamp turned on. So we're going to turn this on. This is only used for sample positioning. It's not used during shooting. Then what we're going to do is we're going to take our bee, our sample, whatever it may be, no pun intended, and we're going to stick it on the stage here in the center of the rotary stage. Now we want to open up the EOS utility. Once you've had your camera turned on, you want to have the camera turned on to your automatic mode. That way you can see everything you're doing in live view. You'll click on remote shooting and go ahead and click on live view just to make sure that the bee or your sample is centered. That is pretty lucky. It's centered almost specifically in the middle. I could raise this a bit higher. Like I said, I have different stages which will allow me to lift the specimen, or sometimes the specimens are sit up a little higher on the needle. I can stick that in a little higher just to get a little bit more added height, but it's not wholly important because we're just going to be shooting this sample at 1x magnification, so that should be plenty of clearance. The next thing I want to do is create a folder wherever my images are going to be going. So I just want to designate a consistent folder where everything goes. For that, on my desktop, I usually have an active 2D if I'm doing just basic focus stacked imagery, or I have an active 3D. In this case, we're going to be doing a video tutorial, and we're using the B, so we'll just have video tutorial B is what it's going to be called. I'll go in, designate that folder to the folder I've just created. Desktop, active 3D, video tutorial B, and open. The next thing that's pretty important is we want to create 72 distinctive folders because in a 0 to 360 degree reference frame, we're going to be capturing one image every 5 degrees, and that's going to be approximately 70. It is going to be 72 final images. So I usually have this little template folder where I've pre-made rotation folders. So they're empty folders, but basically there's 72 of them from 0, 5, 10, all the way up to 360 degrees of rotation. So I just copy and I paste those into the project that we're working on. This is the video, again, the video tutorial B folder where I've just designated our images to go. Now what I want to do, now that the folder is set up, most of the equipment is set up, I just want to turn on the StackShot controller and I want to open Live View once more. Because now we're going to go through and we're going to set up the x-axis, which drives our focus stacking, and then we're going to set up the y-axis, which is going to be driving the rotary stage and the rotary turntable. And then we're going to show you how to combine the two of those so that you can produce the 3D model without having to be present. So, in this case, we're going to start with the x-axis. We're going to be using a somewhat of a higher aperture. So in this case, we're going to be using 35 steps. If you have to change that from a number you already have, remember you click on steps, you just input the number of photographs you want to capture per stack. Now what we want to do is move the sample to and from the camera. And in our case, we want to move it towards the camera, because what we're going to be attempting to do is focus on the very back portion of the bee. So you can see here, there's my antenna. We just want to go just so that it's out of focus. But you don't want to choose start yet, because now what we want to do is click on the X here to switch it over to the Y-axis. We just want to start rotating the bee just to make sure that no other portions of this bee come into focus. You can see how the antenna, it's starting to be in focus again, which means that we need to reposition the sample along the x-axis. And we'll just keep it going. You can see how the legs are coming into focus, the wings are coming into focus. So what we want to do is stop it, go back to the x-axis, and we want to bring our sample closer, just so that we know we can capture complete depth through this bee when we focus stack. So there we go. Now we're somewhat past the bee. Everything looks to be out of focus again, but let's just confirm. So we're going to continue to rotate our specimen. The wings, there they are. They're in focus again. So we're gonna bring it forward just a bit more. Go back to Y. Keep it turning, and we know that our antenna, once we were facing the other direction, was in focus and out of focus, so we should be completely clear. So that's a good starting point for our x-axis. We're just going to go back to X, hit set, and now we want to set the end position. So now we're going to move the sample away from the camera so that the focal plane moves through the subject, towards us, towards the camera, and now we want to try to do the exact same thing. We just want to start rotating the specimen on the y-axis and just make sure that there's no areas that come into focus. Here the tips of the wings are. So we'll go back to X, push the bee a little bit further back. Everything's out of focus once more. Go back to Y. Keep it rotating. And that looks to be pretty good. That looks like it was the area on the specimen that was the closest to the camera. So it looks like we should be completely in the clear. So now we can go back to our x-axis and we can set our end position. Now our focus stacking parameters are set up along the x-axis. The only thing left to do is set up the y, which is much simpler because we're doing a full 360 degrees. All you have to do is line up the 0 with the 0 that's above the Cognisys label. So there's a 0 on the turntable as well. We just want to make sure that we're at the starting point. So here we go. So now my zeros are matched. I've got 0 and 0. I want to select my starting point, and then I want to hit the downward facing arrow so that we're basically moving up in numbers. So now it's going to 45 degrees. Now it's at 90 degrees, but we want to do this until we're all the way back to 0. So that way we know that we're going to get the entire perspective of this bee on this viewing direction. So just about there. And remember, we're going to be shooting this bee in 5-degree intervals. The more intervals you have, the better the 3D model, because the more data that Agisoft Photoscan has to work with, the better the output 3D model. But there's different ways to do that. I prefer to shoot my specimens in 5-degree intervals, and then if I need more data, I'll just reorient the pin so that I have a different perspective, and then repeat the same process later. But if we have to do that for this demonstration period, that'll come in a later tutorial video. Again, for the number of steps, we want to use 72 because that's 360 divided by 5. That means that basically, again, the motor is going to stop and allow a focus stack subset of images to be captured every 5 degrees. So again, if you're not at 72, you'll click on the 72, you'll input that number and hit the check mark. The X and the Y axis are now completely set up. What's left to do now is turn your camera back to the manual mode, and we're just going to set up our lighting for this shot. So I'll turn the flash on. I've got my diffusers. You can position these a little bit further in because these blockers we're so close to the sample here that these blockers are going to block out any direct light. So if you just face these towards the specimen, we're going to get more light projected onto the sample, and it'll still be really nice and diffused for us. So what we're going to do at that point is open up our quick preview. Now I'm at 1x, so we don't need as much light as we would if we were at 5x magnification. So what I'm going to do is exposure always 1/200. Like I said, the aperture is going to be a bit higher, so it's going to be at f6.3. I'm going to start with an ISO of 250, which is fine to bump it up from 100 if you're doing a 3D model, especially when you're gonna close the aperture down a bit. And then also for white balance, we want to make sure that that's not on auto. Like the reflector white balance, that way the white light is getting reflected. It's going to be indicated in all the images. White balance is going to be consistent across the board. So again, we have the ISO at 250. I've got the flash currently on at 1/16th power. Let's just go ahead and capture a picture and see what our lighting looks like. Before we do that, we want to turn off our desktop lighting so it's not interfering. Capture an image, and we'll see what we have. You can see that the white background, again, this is kind of how I have that neutral gray appearance, just because it's so far in the back, which is perfect for what I want. I'm just going to rotate the system a bit because it looks like I'm off the felt. So we'll capture another picture just to make sure that that background's nice and consistent. And there it is. It's perfect. So now it seems like everything is pretty good. Those are good setup parameters. Our lighting's good. Our lighting's diffused. You can see that even on this stand, which is just ABS 3D printed plastic, the reflection is very low compared to what it would be if you were just using direct light. So now what we want to do is go ahead and we want to tether the X and the Y axes. So to do that, you're going to click on the Y, the Z, and now we're on a page here, which I'm just going to hit change settings. It asks me, do I want to link the axes together? Of course I do, yes. So we'll start with the X-axis. It says the X-axis step once before moving on or complete the entire stack. We want the X-axis to complete the entire stack and then rotate. So we want to press complete. Now for the Y-axis, when it is ready to move, does it step once or does it complete the entire stack? The Y-axis is going to step once before completing a stack because the whole stack is the full 360 degrees. We want it to just do once, go back to the X-axis, and then capture another subset of photographs. So we're going to click step, and then do you want to include the Z-axis? We don't need to include the Z-axis. So now we're completely set up and ready to go. So what I want to do is go back to my desktop, and then I want to navigate to the folder, which is Active 3D, and those test images that I captured beginning, that's 17/5/8, that's today's date. I'm just going to go ahead and delete those. And now I'm going to go through, I'm going to press start, and that is going to initiate the process of capturing the data that we need in order to basically develop and build a model. Okay, so that's the end of the second tutorial, which is just setting up and capturing the photographs, which we're going to use for the 3D model later. If I missed anything, if you have any questions, please feel free to comment in the comment sections below. I'd be happy to address your questions. But for the most part, this should be a good overview as to what you should be doing before building a 3D model using Agisoft Photoscan. Stay tuned. The next tutorial will come soon, which is going to be processing and assembling, separating out this data before the fourth tutorial video, which will be actually building the 3D model using Photoscan. So thank you very much for your time. Thank you for watching. And again, if you have any questions, please leave them in the comment section below. Thank you.